Good afternoon, everyone. We are Revitary. Today, we are going to present the BIM AR-based visualization through Microsoft HoloLens. First, let's discuss the existing problems in construction industry. One of the problems is the collaboration issue. The fragmentation of communication with contractors is common, meaning that the contractors seldom update the progress with clients and the consultants, and they work separately. This is mainly because construction industry rely heavily on manual and paper-based workflows. Eventually, conflicts may happen to the parties due to the lack of collaboration. Moreover, construction industry have low sustainability. The reliance of printing 2D drawings leads to the paper wastage. Without the tracking of materials, contractors would waste the materials and clients cannot manage it properly. Mainly, it is because of the manual control of site activities, which bring cost overrun and delay of projects. The third problem is visualization challenges. Visualizing three-dimensional world in 2D drawings is difficult. Misunderstanding or interpretation of the drawing can easily happen to different parties in the project. Errors can easily happen. Eventually, project delay and cost overruns will be caused. Regarding the technical obstacles, last-minute changes are common in construction industry. It is because issues cannot be foreseen without BIM and AR. Meanwhile, technical issues are not easy to be solved. Rework will be common in this case and brings adverse impacts to the management of projects. Now let's discuss the AR and HoloLens. Augmented reality (AR) allows direct or indirect view of real-world environments, adding with the virtual computer-generated information. The whole experience facilitates the interactions with the real world. This technology identifies the issues, minimizes the misunderstandings, and achieves collaboration working environments for the users. In our trial, we can visualize complex 3D data such as our Revit model in the HoloLens and work collaboratively with my groupmates through Trimble Connect. Moreover, a large amount of construction costs can be saved when applying HoloLens. Let's watch a video of us using the HoloLens. Here is the features and applications of HoloLens with BIM. First, HoloLens allows construction stakeholder shares captured videos and images instantly. Second, every operation of the HoloLens can be conducted with hand gestures, voice command, and spatial mapping, which is very convenient. Third, HoloLens constantly update the ecosystems, which ensures security, reliability, and scalability. BIM and HoloLens can be applied in design stages. Architect can firstly generate the BIM model and export it to the HoloLens. Clients and architects can then visualize the building through AR. Any design adjustments can also be made together in a real-world environment. In the planning and management stage, clients can carry out 4D simulation in BIM. Data management can also be conducted by the clients through Trimble Connect shared drive. The shared drive can connect with all stakeholders in the project. During the construction, clients can carry out remote instruction to the contractors. Meanwhile, 3D scanning by HoloLens can be achieved to conduct quality control. Clash detection and clash check can also be visualized by all parties on site, so that all problems can be identified immediately. In the post-completion stage, trial maintenance for workers can be accomplished through HoloLens simulation. Besides, performance of facilities can be monitored from the 3D database with real-time comparison of facilities efficiency.
Below discussed the CDE and HoloLens we have adopted. BIM allows the production of a multidimensional digital model for visualization purposes. In this focus study, we have used Revit to produce the finalized design of traditional housing model. Common data environment is used for real-time synchronization of building data. We have used Trimble Connect. As shown on the screen, we have used Trimble Connect to make comments on our individual unit designs and used for collaboration during our design stage. Microsoft HoloLens is then used as an AR device in the IC to visualize the building design and details. In the industry, it is used to keep track on the progress and, for instance, by comparing the site conditions with the model. Here are the practical applications of AR and HoloLens during our 4 trials. We first load our BIM model through Trimble Connect to our HoloLens. Then we use hand gestures to drag and drop and position our model to our physical world. Here is the residential block of our model. We successfully walk through its corridor and rooms by smoothly moving with a swivel chair. We can see its building components, including doors, windows, slabs, and so on. Further going through our model, here is our office and communal space. The immersive experience of augmented reality technology in visualizing BIM designs allow us all to see the proposed details and renders. For example, the office area, table tennis courts, convenience stores, etc., enabling our first-person experience in the virtual space in our model. In reality, clients can then better understand their project outcomes. Before these successful attempts, we have actually spent sweat and tears during the countless failed attempts. The first challenge we encountered is that we constantly see through the structures like false ceilings, which was actually useful for engineers to inspect the plumbing drainage systems and defects, but very undesirable for clients or users like us. Another issue is that we retrieve our model through Trimble Connect, but it often got disconnected. It sometimes freezes, and during the demonstration session from IC, the Trimble Connect couldn't even load. Apart from that, we encountered lagging due to limited processing power. Models with over 100 MB size could not even be loaded, and we have no choice but to convert the file into IFC format or cut it into fragmented parts in order to be loaded. Other problems also include significant battery drops, blurry displays, or frequent disconnections. There are also issues with hand gestures, as it's the only way to control the model or provide inputs. It often causes typos when logging in to retrieve the files in Trimble Connect, and failure of drag and anchoring of our model to our desired positions, like what's been demonstrated in this video. AR does not have teleportation functions, which requires large physical space and may cause clashes. It is observed that the image inside the transparent screen of HoloLens was not sharp enough, and HoloLens has no advantage compared with the traditional 1080p LCD monitor, and unwanted vibrations also occurred that deteriorate users' immersive viewing experience.
In here, we'll talk about trends and prospects of AR. In our trials, we found that Wi-Fi, large file, and software crashes, responsive hand structure, and soft battery life have contributed to our technical issues on using AR. Furthermore, with only 10.3% of construction companies are using AR, there is insufficient training on using the AR headset. Furthermore, with only the little changes to the AR model, we found that there is no connection with the real-world environment, and there is little changes to the model. In the future, we hope that with the use of Wi-Fi 7, 5G, and ultra-high-speed network, the wider range and lower latency mode, and new battery to promote a more convenient experience of AR. For example, with the meta projects like the Horizon World from Facebook, we could be a pull factor to increase AR popularities and increase penetration rate. Last but not least, the IoT development with the smart operation monitoring to help to increase the real-time tracking and increase connection between real world and AR. Finally, we'll talk about suggestions and conclusion. Our first suggestion is to enhance the hardware performance of Microsoft HoloLens. For example, the better MR interface solutions like the new design MR application, which will avoid switching, and then it will reduce less technical and human mistakes from hand structure. Furthermore, we could enhance the frame designs, for example, better display, brighter backlights, and high resolution, help to increase the viewing experience. Last but not least, the improvement of sensors, for example, better movements, the introduction of controllers, it will increase the hand structure experience and the performance. Our second suggestion is to have the new ergonomics design for all the users. For example, we will separate the components with only display on the headset and a SOC battery in the backpack and connect them with the portable fork to improve the mobility. Also, we will use bigger and larger batteries for longer continuous use on the AR device. Last but not least, to use a more durable materials, for example, more shock-resistant and impact-resistant materials to help reduce the risk of injuries. For our last suggestion, we would like to promote the use of AR in the construction industry. For example, to make it a mandatory use in the government projects, for example, like how BIM and AC is required in government tenders. Also, we will have subsidies on AR training courses, for example, including these courses in the continuing educational fund to increase the supplies of skilled workers. Also, we would like to have a better infrastructure for AR, for example, better network and also additional lessons. Overall, we found that the experience on using Microsoft HoloLens is amazing, but there is still some technical issues, for example, detection, collection, display battery, and CPU use, and also there is lack of experience for the industry due to no training and tutorials, and also the separated world due to the no physical relationship to the realities. But still, there are also solutions, for example, the innovations like 5G and more trainings could be provided with the industry, and last but not least, the demands of high for AR infrastructure.
Here are our references. That's the end of our presentation. Thank you.